quiz on Friday. It will be over your 52 elements, names and symbols. Now, you are welcome that it's not today, all right? The reason is because I didn't tell first hour to do that by looking at their elements. But you do need to know your names and symbols if you plan on being successful on this next test, which is next week, all right? So this is a very short topic. However, it is extremely important that you know how to name compounds or write formulas. So it is imperative that you know the names and the formulas, or I'm sorry, the names and the symbols. All right, so we will talk about them today. You'll get some practice on writing some of the names and compounds. We're going to go over the basics today, and then the next couple of days we'll get a little more intense. But the next time that we meet, you will have a quiz, so be prepared. Be studying. I saw some flashcards out this morning. That was very good. But we need to know these for the rest of the year. From this point on, you have to know your 52 names and symbols. It is easy. Yeah, you use it enough. All right. So again, what we're going to do is, and this is a little bit of a different change. Of course, you don't know any different. But we're going to start off with ionic compounds today, or this before fall break. And then we'll go over the non-metal with the non-metal, and that'll be a whole different naming rules. We have some vocab on here, not as much. The first thing that we want to talk about, you can go ahead and get the blanks here. And you do want your periodic tables out. When we're naming compounds, you must have your periodic tables out, unless you have it memorized. And I'm talking not only the symbol and the name, but also the oxidation number, which appears on the periodic table, which I'm willing to bet nobody has that memorized. Oxidation number. When we talk about oxidation number, especially when we're writing ionic compounds, we're talking about the potential charge that an element may have. And for what we're doing with ionic compounds, the metal and the non-metal both have a charge. And we'll talk about how do you figure out what the charges are. But again, we're looking at a ratio of how many metals we have with the non-metals when we write out these formulas. And it's really nice. I mean, once you get this pattern down, you're going to go, wow, this is pretty easy. If I know my 52 elements, names, and symbols, this is easy. Super, super easy. But if you don't know your 52 elements, names, and symbols, you're going to be struggling for a while.
So are we only going to be using ones that deal with the ones we know?
That is correct. Yeah, we won't be working with any of the other elements. It's only the 52. Hence the reason why I want you to memorize those 52. What we're going to be talking about today are monatomic. Mono, meaning one, so we'll have one type of metal, one type of non-metal. A little bit later on, I think maybe Friday or next week, I can't remember when we do polyatomics, means that we have more than one metal or more than one non-metal, and I mean by different kinds. So polyatomics deal with more than one, monoatomic deals with one type. So with the ionic compounds, we're always going to have a metal with a non-metal. All right. Chemical formulas. A chemical formula tells you what type of atoms you have. It's kind of like a shorthand version for writing out chemical names. We'll be using subscripts. That'll tell us like how many atoms we have. Like we all know what the symbol or the formula for water is. What is it? H2O. So the H symbolizes that we have hydrogen. The 2 symbolizes that we have 2 of them. And the O means that we just have 1 oxygen. What we don't want to do is write subscripts for the number 1. In other words, if you have at least one of the elements represented, you don't need to put a subscript 1 there. That's why we don't call it H2O1. Yeah, you already have 1. You don't need to indicate that. However, if you have more than 1, tell us how many you have. Formulas of compounds. Every compound is represented by a specific formula. That helps keep the confusion down. Now, in some cases, we might be working with elements that could have different combinations. And we'll talk about that, I think, next week. I'm pretty sure that's next week. How you're going to be able to differentiate whether this iron atom has a +2 charge or a +3 charge, because it could have either. With ionic compounds, we always want to work with the smallest whole number ratio. Now that isn't always the case when we get nonmetals with nonmetals. However, with ionic, smallest whole number ratio. So, like for example, sodium chloride, okay, some of you might initially write that out as Na subscript 2 Cl subscript 2. Well, if you have two sodiums, two chlorines, reduce that down. And here's two examples where copper can either be a +2 charge or a +1 charge. That's a little bit later down the road. When we do that, we have to indicate the difference by putting the subscripts in there to tell us, okay, copper is a 1-to-1 ratio here. Here it's a 2-to-1 ratio. All right, so I'm just giving you some backgrounds. I'll give you the actual rules right now. All right, the rules for writing out the formulas. Rule number 1, obviously, represent each kind of element in the compound with the correct symbol. So if you're writing out sodium chloride, don't put an S for the sodium, because that represents what? Sulfur. So we're not doing sulfur chloride, okay? We're doing it with the correct symbol. So obviously make sure you put the correct symbol for the element. Number 2, use subscripts to indicate how many of the atoms you're going to use, unless the subscript is 1. And in that case, don't use a subscript. If you have at least one representative, you got it. Okay, if you need to show more than one, then put it. We will talk about, oh, right here it is. I think I put this ahead. Rule number 3, write the symbols, or write the symbol for the more metallic element first. And with ionic compounds, it's very easy. You put the metal first. This will have a little more significance when we work with nonmetal. But here is our chart for metallic properties. Again, they decrease as we move to the right. They increase as we go down. So obviously the metals are over here. The nonmetals are over here. Okay, so write your more metallic element first. So if you were given sodium chloride, don't write the chlorine first. Write the sodium first. Okay?
Well, isn't it the way you say it too?
If you say it correctly, yes. But I may give you on a problem, okay, you've got a compound that has chlorine and sodium in it, write the formula. I've been known to do that numerous times. So don't be automatic and go, oh, this compound has chlorine and sodium. Put the sodium first.
Okay.
I think I have some of those examples. And here's an example of lithium oxide. And I'll explain why there's two lithiums here in a moment. But looking at this compound, again, the Li represents lithium. This is lithium oxide, and we'll do the naming components here. But again, lithium has is a more metallic element, so we write it first. Oxygen is the nonmetal, so we write it last. The subscripting indicates that we have two lithiums. Notice there's no subscript for the oxygen. Okay. And again, how did they figure out that it was a 2-to-1 ratio? They went into the lab and found out. There's some things that you can do. We won't do it in here, but we can find out the ratio. We will probably have a stoichiometry problem a little bit later on, but we have to wait till we talk about stoichiometry first. Yeah, Lewis.
What's the fast way to memorize your periodic table?
Why do you want to memorize your periodic table?
Because I don't know it.
I think he means
Okay.
Yeah.
Here's my suggestion. This is a tool. Have it in front of you. Okay. You never have to memorize this. You just have to know the names and the symbols.
That's what I mean.
Oh, flashcards.
Oh my goodness. We've already taken a good
Yeah, and I failed both of them.
All right, formulas and names of ionic compounds. Again, we want to go with the smallest unit for the molecular compound capable of retaining the chemical properties. In other words, what that's saying is we're going to have the smallest whole number ratio when we do this. Again, you will have a metal with a nonmetal. And what do metals like to do with their electrons? Lose them. Very good. That's why metals will be positively charged, where the nonmetals will gain those electrons. And again, all the things that we learned before this, where metals want to have the same electron configuration as their nearest noble gas, that means they're going to lose electrons, where the nonmetals are going to gain those electrons. to have the same electron configuration as its nearest noble gas.
Oh, you're still practicing?
No. I think we might all be close to being done here for today. It's necessary to know the charges for each of the things, and I will throw a periodic table up here in a second and have you write some information for the nonmetals. Because some of the nonmetals have more than one charge, but for what we are doing right now, we only care about a certain charge. Okay. All right, so using the ion charge to predict the formulas, again, the charge is going to tell you what the ratio is. The charge will tell you what the ratio is. And predicting the ion charge from the periodic table, if you're looking at a metal, say in group 1A, what do you think the charges for those are? 1. Why? It's in group 1A. It has 1 valence electron, so it's easier to lose that 1 than gain 7 more. Good. And we'll use that information to help us determine the charges. All right, so here are the rules for naming the compounds. We've already talked about the basics. Rule number 1, name the elements in the same order that they appear in the formula. So if I've given you the formula correctly, say like not you have a compound with chlorine and sodium, but I said, okay, you have sodium chloride. So we're going to write it in the same order that they appear. Then we're going to drop the last syllable, or in some cases, 2 syllables. Now again, when I learned how to do syllables, it was like this. Sodium. Okay, I think some of you did sodium. All right, but this only applies to the non-metals, so the metals will retain their name. So if I'm looking at, say, chloride or chlorine, okay, we'll look at chlorine. We're going to drop the last syllable, which is ine or ine, and put ide. So right here, the IDE ending. So it goes from chlorine to chloride. Notice now we have sodium chloride. The ions formed from the elements in the alkali group have a +1 charge. We already know that. Yes, Steph.
So but like oxygen?
Oxide. Very good.
But
We're going to drop the last 2 syllables.
+2 syllables?
Yeah, either 1 syllable or in some cases the last 2. And we'll go through all the non-metals. Nitride. Nitride. And like for sulfur, it goes sulfur. Well, we kind of change it up and just go sulfide. You'll get used to hearing it, so bear with us.
Yeah.
All right. Elements in group, the alkali earth metals, group 2A, they like to have a +2 charge. Rule number 4, aluminum ions have a +3 charge. We really won't look at the other metals yet below that, but they also have a +3. And then I like this, other elements have various charges. That's a cop-out. Nonmetals. Let's look at the periodic table here. And I want you to write this if you have a pen or a Sharpie. Here's what I want you to write on your periodic table, but I don't want you to write it on my periodic table that I give you on the quiz. Okay? All right. Everybody look. Looking at group 7A, okay? The nonmetals, the group 7A nonmetals. How many valence electrons do they have? 7. How many do they need to gain to have the same electron configuration as their nearest noble gas? 1. So right above fluorine, I want you to write -1. Okay? -1. That way, when you look at the nonmetals, and the reason, and you have to listen, because some of you are going to ask this question later on. I swear, it always happens. Some of you are going to go, well, which charge do I use? Chlorine's got like 4 or 5. Which charge will you use? Thank you. -1. We're going to use the most common charge. We won't talk about these other charges till later. Don't worry about them yet. Later. Okay?
Group 6A.
Group 6A would have what charge? -2. Very nice. Now what about group 5A? -3. Okay? So -3, -2, -1. So when we're writing out our formulas, you can look at your periodic table real quick and go, man, what is the charge? Especially with nitrogen. What is that? +1, -1, +2, -2, +3, -3, 4, and 5. So that's like 8 charges that nitrogen can have. But when we're working with it, it'll have a -3 charge.
What
Okay?
about group 3A?
3A has a +3. That's why they have all these 3s. Now, the numbers that I'm referring to are these blue or green, whatever the charge is on your periodic table. I think it's blue. Okay. So those are the oxidation numbers. And notice that some elements only have a single charge. Some have more than one, and we'll talk about the more than ones later on.
What's 4A?
We're not going in 4A's pond, because it could either be plus or minus 4. So we'll stay out of that.
What about, so we're saying out of 3 too?
Yeah, so we'll go either 3 or less, or 5 or more.
So we need to put plus 3 on.
No, you don't have to put anything else because there's no question. They're 3s. You can see the 3s. The reason why I had you put a -3, -2, -1 is because a lot of these have more than one charge.
Can we put it there anyway?
Okay. So again, these last couple ones state that nonmetals in group 5A have a -3 charge, 6A have a -2 charge, and group 7A have a -1 charge. So we just went over that. Write the symbol for the metal first. We already talked about that. And then the non-metal last. And here is the most important rule, number 7. Make sure that the algebraic sum of the metal with the non-metal equals 0. Okay, so we want to make sure that the algebraic sum of the charges equals 0. Until I tell you otherwise, you're writing everything to equal 0. Now there are some compounds that don't have a charge of 0, but I'll tell you later. Today, this is what we're doing. Let's do baby steps. What's that?
What does that actually mean?
Good question. All right, let's look at the first example here. And actually, I'm going to turn the lights on so you guys can see. All right, we're on page 4, and again, have your periodic table out. Now you can actually see. Number 4. I'm sorry. The first example at the bottom of page 4. It says, predict a formula for a compound that contains calcium and chlorine. All right, so first of all, when you see something like that, calcium and chlorine, who's the metal?
Calcium.
Calcium. What's the symbol for calcium?
Cl.
Ca. And chlorine? Cl. Okay, so we'll write it just like that. Now, and this is what I do each and every time. And I would highly recommend you do it as well. What is the charge for each calcium atom? Plus 2. Write a 2 above it. Plus 2. What's the charge for each chlorine?
-1.
Minus 1. Now, as I have that written, plus 2 minus 1, does that equal 0? No. So we want the algebraic sum to equal 0. So what do?
We need another one of those.
So we're going to multiply this by 2. So plus 2 minus 1 times 2 equals 0?
Yeah.
Good. Whatever's in the parentheses, that's your subscript. Okay.
Well, I can do that. That's how you figure that out. Wow.
So that's the algebraic sum. Now, what is the name of this compound?
Calcium chloride.
Calcium chloride. Very good. So we're leaving the metal name as is. You don't ever change the metal. So it's calcium, and then we have chlorine, but drop the INE and add IDE. So calcium chloride. Isn't that cool?
Let's do another one.
Let's do another one. Turn the page. Number 5, or page 5. All right. Here's some more practice problems. It says, write the formula for the ionic compounds that would be created when these elements react or combine. So we have magnesium and oxygen for that first one. What is this? Who's the metal? And I'm going to ask that because I did switch up some of these. So magnesium is Mg and oxygen O. What's the charge for each magnesium atom? Plus 2. Oxygen? Does that equal 0?
Yeah.
And what's the name of this called?
Magnesium oxide.
Very nice. Magnesium oxide. Very good.
I know. Awesome.
So look at the next one. Aluminum with bromine. So who's the metal? Aluminum. And the symbol for aluminum? Al. And bromine? Br.
So they don't have to be in the same line.
What? Oh, no. What's the charge on aluminum?
+3.
Plus 3. Bromine? Minus 1. Does that equal 0? What do we need to do? Divide by 3. And what's this called?
Aluminum bromide.
Aluminum bromide. Isn't that nice? Sodium and sulfur. Who's my metal? Sodium. And how do I represent sodium? Na. Oh, hold on. Let's not go there yet. And sulfur? S. All right. What's the charge on sodium?
1.
What kind of 1? +1. It's a metal. Good. Sulfur?
-2.
And does that equal 0? So what do we need to do?
Multiply sodium by 2.
Good. And what is that called?
Sodium sulfide.
Sodium sulfide. Very good. Okay. Oxygen and aluminum.
Aluminum goes first.
Aluminum goes first. Very nice.
I was like, I got this.
And what's the charge on aluminum? +3. Oxygen? Does that equal 0?
No.
Oh, now's a good point.
You gotta.
Hang on. What we cannot have is fractional subscripts.
Oh, thank God.
Okay? We cannot have fractional subscripts. We have to have whole numbers here. So, if we have a 3 and a 2, what do we need to do? Good. I like all of these answers. So we need to multiply the 3 by
2
and the 2 by
3.
So in some cases, we may have to do both of them. What's the name of this compound?
Aluminum oxide.
Very nice.
This is nice because we're kind of doing this then. So you put the metal first.
Always.
Like,
The more metallic element is listed
like
first.
factory right now. So I guess I'm
Okay. What's the next one? Potassium and nitrogen? Who's my metal? And how do I represent that? Okay. And what's the other one? Oh, nitrogen? How do I represent that? N. So potassium is
+1.
nitrogen
-3.
-3. So what do we do?
Put a times K by 3.
Good. And what's that called? Potassium nitride. Very good. Bromine and cesium, or cesium, however you want to pronounce that. Who's my metal? Okay, so what's the symbol?
CS.
CS. And bromine again is Br. What's the charge on cesium or cesium? +1. Bromine. Are we good? Now what's this called?
Cesium bromide. Cesium bromide.
Either way you want to say it, I don't care. So cesium bromide. Good.
Ooh, you did this wrong.
I did what wrong?
Iodide.
Yeah, it should be iodine. You're right.
He already gave away an answer.
Ooh.
So potassium, how do I represent it? Okay. And iodine. So what's the charge on potassium? And iodine?
-1.
Does that equal 0?
I don't think it does.
So what's this called?
Potassium iodide.
All right, and the last one, oxygen and magnesium. Who goes first?
Magnesium.
And the second one? What's the charge on magnesium and oxygen?
+2 -2. Hey, we already did this.
Crazy, right? All right. Let's put that back up. So the one word, we'll talk about dissociation a little bit later. And this is more of an ionic thing when it gets into water, how it breaks apart. So just have it. We'll talk about it later. All right. Let's take a look at now. I think I gave you the names. You give me the symbols. Now I'm giving you the formula name, and you're writing it out.
Is it 2 separate words? Calcium oxide.
It would be, right. So, and whenever I'm giving you the formula, now listen carefully, guys, because I don't want this to ever be confusing. If I'm giving you the formula, it is balanced. If I'm giving you the name, you write out the correct formula, all right? So don't ever go, you didn't write that correctly. Now, every once in a while, especially on the homework, I might do something, but I think they're all good for now. So, first example, we have, what is Ca again? And the O is oxygen, so we're going to drop the last 2 syllables and make it oxide. So this would be calcium oxide, 2 separate words. It's 2 separate words. So calcium is 1 word, And then oxide, O-X-I-D-E, is the second word. Okay.
Is this giving us practice?
No, it doesn't need to be capitalized. It's not important. The only thing, and that's actually a good point, the only thing that needs to be capitalized is the first letter in the symbol. Okay. The names you don't have to capitalize. And I don't think I did that with these. I didn't capitalize these, so yeah, you don't need to. All right. KBR. Potassium bromide. Very good.
This is giving us practice on our own.
What is that?
This is giving us practice on our own.
This is giving you practice on this?
Yeah, like learning it because we obviously have to know. Like,
Yeah. What is the second one? The CS2O. Cesium oxide. Very good. Okay. Now, here's one thing that I haven't said yet. The subscripts, for now, don't really change the name. When we get nonmetals with nonmetals, that rule will change. But for now, live the dream. Don't worry about the subscripts. Okay, other than writing out the correct formula. So this Mg3N2 is what? Magnesium nitride. Good. And the reason why we have 3 magnesiums and only 2 nitrogens is because nitrogen has what charge? -3, where magnesium has a +2. So what I don't want you to do is get in the mode of just saying, if I just show one of each, we're good. No, if you're writing out the formula, make sure that we're doing the algebraic sum. All right. BaBr2. Barium bromide. Barium bromide. What is Na3N?
sodium nitride. Wait, no.
What is it?
Sodium nitride.
Sodium nitride. Sr3N2. Strontium. Good recovery. Strontium nitride. K3P. Phosphide. Good.
Okay, how do you spell that? Is it F-H?
It's
O-S-P?
P.
I mean, did I say F? You said F-H. No.
So pH.
P-H-O-S-P-H-I-D-E.
Sounds good.
Okay.
Yeah, instead of writing phosphorus, and the O-R-S gets out, and you put the I in there. Phosphide.
When you go to the dentist, and like, you get the chloride treatment, is that made of chlorine?
It is. Yeah. And you have fluorine in your toothpaste, which is your fluoride. It's actually, most of the time, it's sodium fluoride.
Wait, is it
Iodine? I don't know. And the last one here, LiF.
Lithium fluoride.
Lithium fluoride. Very good.
It was awful. I was like,
Okay.
what am I doing?